Let's talk about how to measure an angle. Angles are measured using something called a protractor, which is the tool that you see on your screen right now. It measures angles in a unit called degrees. On this protractor on the screen, the degree measures are the ones that go along the curved side of the tool. These other measurements are actually just a ruler. These little measurements are centimeters, and these larger measurements are inches. They're used for measuring straight lengths. But if you want to measure the size of an angle, then you have to use the curved side of this protractor, and it gives you a degree measurement. In order to measure an angle, you'll want to place the vertex of the angle at the hole at the bottom of the protractor. And you'll need to line up one of the two sides of the angle along the straight line that goes through that hole. So either you'll have a vertex at the center and one side will go off to the left, or that side will go off to the right. And then the other side will be swinging out here somewhere along these measurements. You'll notice that there are two different sets of measurements as you go around the curved side of this tool. So how do you figure out which measurements to use? Well, it depends on which direction your starting side is pointing. If you lined up your vertex and the starting side came this direction, then you would want to use the outermost ring of measurements because they start at 0 on this side. You always want to start at 0 when you're measuring. However, if you had placed your vertex at the center and then your starting side pointed this direction off to the right, then you would want to use the inside markings because those are the ones that start at 0 on this side. Let's take a look at a couple examples. I want to measure this angle right here. Spoilers, it's 63 degrees. Well, how did I figure that out? Let's move this protractor so that the vertex is lined up with that little hole in the center at the bottom. And one of the two sides got lined up with the straight line that goes through that hole that we lined up the vertex on. Since our starting side is pointing in this direction, it comes off to the right, we're going to want to use the inside markings of this protractor to figure out my angle measure, because the inside markings are the ones that start at 0. The other markings, the outside ones, start at 180. It wouldn't make any sense to start at 180. We need to start at 0. So this side starts at 0. We need to figure out where does the second side of this angle cross the protractor. And it crosses right here. So again, don't get confused. Just because there's two different markings here, two different numbers, doesn't mean that there's two different measures. We're starting down here at 0 and using the inner markings to find our measurement. So it looks like this crosses at about 63 degrees. Let's try another one. Again, I need to move my protractor so that the little hole lines up with the vertex, and one of the sides is lined up with the line that goes straight through that hole. So I'm going to move my protractor like so. The vertex is on the hole, and one of the two sides lines up with this line that goes through the vertex. This time our starting side points to the left, so that means I'm going to want to use the outside markings to calculate my measurement, because the outside markings are the ones that start at 0. So this side starts at 0. Now we need to figure out where the other side crosses. And it crosses right about here, and since I'm using the outside markings, I can say that the angle measurement is 41 degrees. So let's try another example. This time the way that my angle is laid out and the way that my protractor is laying doesn't really match up. Remember that one of these two sides needs to be laid along this line that goes through that hole at the bottom of the protractor. So I need to rotate my protractor around like so that now you can see that this line that goes through that hole and this line that goes through our vertex are in the same orientation. Then I'll move my protractor so that the hole and the vertex line up. Since our starting side again is pointing to the left, I'm going to use the outer markings to measure this angle, because those markings start at 0. However, we have a problem. When I try to figure out where the other side of my angle crosses through my protractor, it's unclear. I can tell it's somewhere between 150 and 160, but I can't really tell exactly where because the line doesn't go far enough. And this is actually a pretty common problem, especially on worksheets where the angles are printed too small, that your protractor is too big to measure it the way that it is. But that doesn't mean it's impossible to find the measurement, it just means that you need to use the straight edge of your protractor to extend one of the sides of your angle. And of course you'll want to extend the side that is pointing towards the angle measurements, not the side that's the starting side. You already know that this side is pointing towards 0, that's why you lined it up that way. You need to figure out where this side is pointing to, so we need to extend this with a straight edge. If this was longer, like so, then you could see that it crosses at about 158 degrees. We classify angles by what their angle measurements are and group them into categories of 90. Acute angles measure between 0 and 90 degrees. Right angles measure exactly 90 degrees. Obtuse angles measure 90 to 180 degrees. And straight angles measure exactly 180 degrees. And then there is another group of angles called reflex angles that measure more than 180 degrees, but we don't really deal with them too much in this class. When you're looking at a diagram, it's easy to identify right angles for two reasons. Reason number one, they're almost always going to be labeled with this handy little square. And reason number two is because they look like the corner of your paper, or the corner of your room, or really any perfect corner. This degree measure is 90 degrees. We call that a right angle, so I would call angle ABD right. Do you see another right angle in this diagram? If you guessed angle CBD, you're correct. And we'll explore this concept more thoroughly later on, but if you have a straight line, and one side of it has a right angle, then the other side must also be a right angle. Let's find some acute angles in this diagram. Acute angles measure less than 90 degrees, so you need something that's smaller than the corner of your paper. In fact, some people, especially younger grades, get taught that it's an acute little angle, and cute means small, so you're looking for a small angle. I actually see two acute angles in this diagram. Angle DBE looks like it measures less than 90 degrees, and also angle CBE looks like it measures less than 90 degrees. So they would both be acute. Now let's find an obtuse angle. Again, some younger grades get taught that obtuse looks like obese, and obese means big, so you're looking for an angle that's big, at least bigger than 90 degrees. And I only see one obtuse angle in this diagram. I see angle ABE. In fact, you can see it has a right angle inside of it, and it goes beyond that right angle, which means it has to measure more than 90 degrees. So it's obtuse. Straight angles are the easiest to identify because you're really just looking for a straight line. Like angle ABC. It doesn't really feel like an angle because there's no bend in it, but that's because straight angles measure 180 degrees. In other words, they're just a straight line. And now you know everything you need to know about measuring and identifying angles based on their measurement.